From your smartphone syncing up with your smartwatch to connecting with colleagues on the other side of the planet, our lives pretty much run on these invisible connections. So today, we're going to pull back that curtain and really dig into the different types of computer networks that power our world, starting from the device in your hand all the way to servers across the globe.
It really all starts with a simple question. Think about it. You've got a laptop, a phone, maybe a smart TV. How do they actually communicate? How does your request for a YouTube video get from your laptop to some server miles away and then back again in like seconds? It honestly feels like magic, but it's all built on a very clear and logical set of rules.
And right at the heart of all that communication is this really fundamental idea, the client-server model. The easiest way to think about it is like a conversation. You've got one device, the client, that's your PC or your phone, and it does all the asking. And then you have the other device, the server, which does all the providing. It's the one that hosts all the information or the service that the client wants.
Let's make this super real for a second. When you log into your online bank account, your computer is the client. It sends out a request basically saying, hey, show me my account balance. The bank's massive, powerful computer, the server, gets that request, it figures out who you are, and then it sends that information right back to you. Simple, right? This basic client-server relationship is the foundation for pretty much everything we're about to talk about.
All right, so let's kick off our journey with the network that is literally within your arm's reach. We're going to start by zooming way in, right into your own personal digital bubble. So this is what we call a personal area network, or PAN for short. It's the network that exists just for you, connecting all the devices in your immediate little workspace. Anytime your wireless headphones connect to your phone or your mouse syncs up with your tablet, yep, you're using a PAN. And the most important thing to get here is the scale. A PAN is tiny. It's all about convenience over a really short range. We're talking less than 10 meters, so maybe about 30 feet. It's that personal connection, usually built on wireless tech like Bluetooth, and it forms the very first and smallest layer of our connected world. Okay, so let's zoom out a little bit now, from your personal bubble to the scale of, say, a single building. We're moving up to the kind of network that connects an entire place, like your house or your office. This right here is the local area network, or LAN, and this is probably the one you're most familiar with, even if you don't use the term. It's the system that links up all the devices within one specific, limited area. That Wi-Fi network that's connecting your computer, your phone, and your smart TV, you're on a classic LAN right now. Basically, a LAN is designed to serve one single location. It could be your house, an entire school, maybe one floor of an office building, or a research lab. Its whole job is to let all the devices in that one spot share resources and talk to each other as efficiently as possible. All right, let's keep expanding our view. We'd gone from your desk to your house. So what happens when you need to connect multiple buildings, or maybe even an entire city? Well, this is where the Metropolitan Area Network, or MAN, comes into play. And just like the name suggests, this network is built to cover a much bigger area than a LAN. We're talking an entire metropolitan region. This is the kind of massive infrastructure that makes things like smart cities possible, connecting traffic lights, public transit, and all sorts of city services. Think about a big university with dozens of buildings spread out over a huge campus. A MAN is what connects the library's network to the science department's network and the student dorms networks. It's the glue that stitches a whole city or a really big campus together. Okay, time for our final zoom out. We're going from the city to the entire planet. This is the big one. This is the network that truly connects all of us across every continent and every ocean. And welcome to the Wide Area Network, or WAN. Now, the key idea here is that a WAN isn't just a network of individual devices. It's a network of networks. It exists over a massive, massive geographical area, and its main job is to connect all those smaller LANs and MANs together. Honestly, the internet itself is the ultimate example of a WAN. Here's a perfect real-world example for you. A huge bank has hundreds of branches, right? Each one has its own LAN, and they're in all these different cities. So how do they all connect to the main headquarters and share data in real time? They rely on a WAN. It's the massive backbone that links all their separate, local networks into one single global system. So let's just quickly put that all together. We start with the LAN for a small area like a school, then we scale up to the MAN, covering a whole city or campus, and finally, the WAN, spanning a massive area to connect everything together. You can see it's just a clear progression from local to metropolitan
to global. Okay, so we've got all these interconnected networks, right? From the LAN at your local coffee shop all the way up to the global WAN. But this brings up a really important question. How in the world do you stay private and secure when you're using these massive and often very public systems?
And this is an absolutely critical question in our digital age. When you're sending your personal information across a huge WAN, how do you make sure that nobody else can get their hands on it? This is where a whole different kind of network comes in, not one defined by physical distance, but one defined by privacy.
The answer is the Virtual Private Network, or VPN. What it does is let you create a totally private, secure connection over the public internet. It uses really strong encryption to act like a secret armored tunnel for your data, completely shielding it from anybody else on the public network it happens to be traveling on. If you want to understand how it works, just think about using an ATM. That transaction is super secure and encrypted, right? Even though it's traveling over the public banking network. Well, a VPN does the exact same thing for your general internet use. You connect through a secure gateway, it creates that protected tunnel, and suddenly your communication is private, just like that ATM talking to your bank. So let's wrap this up. What are the big takeaways? First, remember that everything, and I mean everything, runs on that basic client-server conversation. Second, we sort our physical networks by how much ground they cover, from the tiny personal PAN to the local LAN, the citywide MAN, and finally the global WAN. And third, VPNs give us that crucial layer of security and privacy that sits on top of all of these public networks. So we've gone on this incredible journey from our personal devices to our homes, to our cities, and then to the entire planet. And it really makes you wonder, right? As we start pushing further out into space with satellite internet and missions to other planets, what's going to be the next scale of network that we need to invent?